You know that feeling, right? You find an old photo on your phone maybe, or you grab a screenshot and it's just
Mm.
blurry, low res, or maybe it's something more critical like a scientific image and you just wish you could wave a magic wand, make it sharp and clear. We've all been there.
Oh, definitely. And it's a huge challenge, technically speaking.
Right.
Real-world images are messy. They've got noise, maybe motion blur, weird artifacts from compression, all sorts of things. And the usual ways of making images bigger often just don't cope well with that mix of problems.
Well, today we're looking at something that might just be that magic wand, or pretty close anyway. It's a new AI system called 4KAgent.
Hmm.
And the big claim is that it can take basically any image you give it and upscale it to a really impressive 4K resolution.
It's generating a lot of buzz, and for good reason. So our mission for this deep dive is to really get into the research paper behind it, 4KAgent, Agentic any image to 4K super resolution. We want to figure out what makes it so versatile, how it actually pulls this off and where this could be used, because the applications seem pretty wide-ranging, from fixing our old photos to impacting things like medical imaging or even AI art.
Right, let's get into it. The paper calls 4KAgent the first unified agentic super resolution generalist system. That word generalist really stands out. Does that just mean it's okay at lots of things or something more? What does it mean for somebody who just wants a clearer picture?
Yeah. Generalist is key here. It means this AI isn't just trained for one specific type of image, like, say, only faces or only landscapes. It's designed to handle a huge variety of inputs without needing special retraining for each one. So you throw almost anything at it, and the goal is 4K output. Or potentially even higher if you run it more than once. And crucially, once it's set up, you don't need to tweak it for different kinds of pictures. It adapts.
Okay, that does sound ambitious. Are we really talking about taking something super low res, like I think the paper mentioned 256 by 256 pixels, and getting a sharp 4K image out of that? That seems like a massive jump.
That's exactly the kind of transformation the research demonstrates. It shows it can handle common stuff like your everyday photos, landscapes, portraits, even really old damaged ones. And it also works on content generated by other AI systems. But it goes way beyond just those typical use cases.
And that's where it gets really interesting for more specialized areas, right? What other kinds of images are we talking about?
This is where that generalist label really proves itself. We're talking scientific imaging things like remote sensing, so satellite pictures for urban planning, for example, fluorescence microscopy images, which are super important in biology for looking at cells, pathology slides, and then various medical images, x-rays, ultrasound, even fundoscopy, which is looking at the back of the eye. The impressive part is how it handles these different types without specific pre-training for each one.
Okay, so how does it actually do this? The paper mentions it's not just one big AI model, but uses an agentic paradigm, a multi-agent system. That sounds like it thinks, or plans. A bit like how a person might tackle restoring a complex image. Can you break down that agentic idea?
That's a good analogy. Think about restoring a really beat-up old photograph. You wouldn't just click one button, right? You'd probably look closely first, figure out what's wrong. Is it faded, scratched, blurry? Then you'd plan your steps. Maybe denoise first, then sharpen, maybe adjust the color balance. You might even try a couple of different tools for sharpening and pick the best result. That whole process, analyze, plan, execute, maybe even backtrack and adjust, that's the core idea behind the agentic approach here. 4KAgent uses three main components that work together to mimic that kind of strategic workflow.
Ah, okay. So it's a more thoughtful process than just running a single algorithm.
Right.
What's the first piece of this puzzle? The paper mentions a profiling module. Is that where you sort of tell the AI what you want?
Pretty much. You can think of it as the control panel. It's where you set the parameters for the job. It's a bit like giving instructions, a system prompt, to a large language model. You can choose things like which specific AI model it uses for the visual analysis part, the part that understands the image. You set the upscale factor 2x, 4x, whatever you need, or you can let it figure out how to get to 4K automatically. You can also specify tasks like I only want denoising or turn on special face restoration. And a really interesting one is setting the restore preference. Do you want it to look perceptually best to a human eye, or be mathematically closest, have the highest fidelity to the original low-res data?
That's a lot of user control. Okay, so you set your preferences. Then what happens? The next component is the perception agent. What's its job?
The perception agent is the analyst. It takes the input image and really studies it. It uses these powerful vision language models we mentioned, plus image quality assessment tools. So it's not just seeing pixels, it's understanding the content, what's in the picture, and it's identifying all the specific problems. Is there noise, motion blur, haze, rain, maybe artifacts from JPEG compression? Based on that deep analysis, it comes up with a custom restoration plan tailored for that specific image. And it also decides the best scaling factor to hit that 4K target.
Got it. So it diagnoses the problems and writes a prescription, basically. And then the final piece, the restoration agent, actually does the work.
Correct. The restoration agent is the executor. It takes that plan and follows it, but it's not rigid. It uses what they call an execution reflection rollback process, which means it tries an operation, looks at the result, reflects on it, and if it's not good enough, it can adjust its approach or even undo that last step and try something else, like an artist touching up their work. And a really clever part is its quality-driven mixture of expert policy, QMOE for short. Instead of just one tool, imagine it has a whole toolbox, maybe 9 specialized models. One for brightening, one for motion deblurring, one for denoising, deraining, fixing JPEG artifacts, and of course the main super resolution part. At each step in the plan, it might run the image through several relevant tools from its toolbox. Then it actually scores the outputs from each tool and picks the best one to proceed with.
A mixture of experts, that makes sense. What about faces? Faces in low-res images can end up looking really weird or losing identity when AI tries to enhance them.
They've thought about that. There's a specific, dedicated, specialized face restoration pipeline. It's like a subroutine that gets called after the main upscaling is done, but only if needed. Its whole job is to focus just on the facial details, trying to make them look good, high quality, but also, critically, making sure the person still looks like themselves, preserving their identity.
Okay, that internal process sounds really sophisticated.
Yeah.
Let's talk results. The paper says 4KAgent sets new state-of-the-art results across, 11 categories and 26 different tests. That sounds impressive on paper, but what does it mean in practice? How much better are the images we actually get?
Well, for the kind of pictures most people take natural scenes, portraits, it means noticeably sharper details, more realism, even if the original photo was really quite degraded. And remember that preference setting. You can tune it.
Yeah.
Do you want something that's technically super accurate to the blurry original, high fidelity, or something that just looks visually stunning, high perceptual quality? You can often choose.
What about those really messy situations? A picture that's not just blurry, but maybe also noisy, and it was raining. Multiple problems at once.
Yeah, those complex multi-degradation scenarios are where 4KAgent really seems to shine compared to other methods. The paper shows examples where it recovers really fine details like the texture on tree bark or tiny ripples in water that other methods just kind of smooth over or make look unnatural when dealing with multiple issues simultaneously.
And that extreme upscaling you mentioned, like 16x, taking a tiny 256 by 256 image to 4K. That seems like prime territory for the AI to just make stuff up or introduce weird artifacts. Does it handle that well?
That's one of the most challenging tests for sure. But the results shown are quite compelling. 4KAgent seems to consistently reconstruct plausible, realistic details even at that massive 16x scale. We're talking about things like the texture of rocks or grass, individual strands of hair on a person or animal, the expressiveness in their eyes. Where other methods might produce a blurry mess or generate details that look artificial, sometimes called hallucinations, 4KAgent seems better at creating fine details that look authentic.
Okay, and what about AI-generated images? We see so many of those now, often created at maybe 1K resolution. Can this help improve them?
Yes, it seems particularly good at that. It can take a 1K AI-generated image and upscale it to 4K, and often the result has richer textures and just looks better aesthetically than if another AI model tried to generate the image directly at 4K to begin with. So it can be a powerful post-processing step for AI art.
Now let's circle back to those specialized areas. Science, medicine, you said it's a universal generalist. How well does that hold up when precision is absolutely critical?
This is really where that generalist capability gets put to the test. In remote sensing, satellite images, it's shown to be effective for enhancing details needed for things like urban planning, reconstructing roads, buildings more clearly. For fluorescence microscopy, it can make faint biological structures, like parts of cells or cell membranes, much clearer and more distinct, even from noisy or dim original data. And this is often achieved with zero-shot generalization, meaning it works well without having seen that specific type of microscopy image during its training.
That zero-shot aspect in medical fields sounds potentially huge. What about things like pathology slides or clinical scans?
It could be very significant. For pathology images, the research indicates it does a good job preserving the complex textures and structures of tissues. It helps delineate individual cells and the overall architecture, which is obviously vital for diagnosis. And across other medical imaging like X-rays, ultrasound, and fundoscopy images of the eye, it consistently shows improved clarity. Better definition of lung tissue or ribs in X-rays, clearer tissue boundaries and less noise in ultrasounds, finer details of blood vessels in the retina.
The potential applications here seem enormous. If we zoom out a bit, where else could this kind of technology make a real difference in the world?
Oh, the possibilities are broad. Think about media and entertainment. Streaming services could potentially deliver 4K quality using less bandwidth, saving costs and energy. Imagine clearer video calls. More immersive video games where the graphics are enhanced on the fly, even at high frame rates. And VR or AR could become much more visually compelling, even on devices that aren't super powerful.
What about fields like security? Blurry surveillance footage is always a challenge.
Right. This could be used to enhance footage from CCTV or body cameras, potentially making faces or license plates clearer for identification purposes. It could act as a kind of force multiplier for existing camera systems, getting more useful information from them.
And for people creating content with AI, artists, designers.
Absolutely. They could use 4KAgent as a finishing tool. Take AI-generated concept art, maybe marketing materials, or even video clips created at lower resolutions, and upscale them to professional, high-resolution quality suitable for print or cinema.
We touched on science and medicine already, but any other broad impacts there?
Well, beyond diagnostics, it could refine research using microscopy, provide clearer data from remote sensing for environmental monitoring or agriculture, and the idea of getting high-quality medical images from lower-dose scans like MRI or CT is really compelling. If you can reduce patient radiation exposure but still get diagnostically useful images, that's a major win.
And what about autonomous systems? Things like robots, self-driving cars. They rely heavily on visual input, don't they?
They do. Better image resolution translates directly to better perception for these systems. Improved object detection, safer navigation, better decision-making in complex real-world environments. This applies to robotics, autonomous vehicles, drones, even enhancing satellite or aerial imagery used in geographic information systems, what they call GI science or GeoAI, for better mapping, resource management, things like that.
Okay, so we've painted a picture of a really powerful, versatile technology with huge potential upsides. But like any big technological leap, there are usually wider impacts to consider, maybe some challenges or downsides too. Let's start with the positive, broader impacts.
Sure. Economically, reducing data needs for high-quality video could lower costs for content delivery networks. It might also enable new services or markets in healthcare tech or geospatial analysis that weren't feasible before. And there's a potential environmental benefit too. Less data storage and transmission means less energy consumption.
What about accessibility? Could this help people who don't have the latest tech or fastest internet?
Potentially, yes. It could help bridge the digital divide, allowing people with slower connections or older devices to still access high-quality visual content. It might also improve assistive technologies for people with visual impairments by making text and images clearer.
And does a technology like this push other industries forward?
Definitely. The need to run sophisticated AI like this efficiently drives innovation in computer hardware specialized chips like NPUs, neural processing units. It also pushes the boundaries of edge computing, trying to get more processing power into smaller, local devices rather than relying solely on the cloud.
Those are some compelling benefits. But we should also talk about the other side of the coin. What are the main limitations or potential concerns with a system like 4KAgent?
Well, one immediate factor is the computational cost. Running these complex AI model takes a lot of processing power, usually high-end GPUs or TPUs. That means significant energy use. So there's an ongoing challenge to make these systems more efficient, especially if you want to run them in real time or on devices like phones.
And the issue of AI bias always comes up. Is that a concern here?
It's something to be aware of, yes. Like any AI trained on large data sets, 4KAgent could inherit biases present in that data. This might mean its performance isn't perfectly even across all types of images or maybe even demographic groups represented in photos. So ongoing testing and work on fairness are important.
You mentioned enhancing security footage earlier, but Doesn't the ability to pull detail out of low-res images raise privacy flags too?
It absolutely does. That's a critical ethical consideration. If you can suddenly make out faces or license plates that were previously unidentifiable or even intentionally blurred for privacy, well, that's a double-edged sword. It really underscores the need for clear guidelines and responsible use, especially when dealing with potentially sensitive imagery.
And finally, in those really critical applications like medical diagnosis, what if the AI gets it wrong? What if it hallucinates details that aren't really there?
That is perhaps the most serious risk in high-stakes fields. The possibility of model hallucinations where the AI generates details that look plausible but are actually incorrect or weren't in the original low-resolution data is real. A hallucinated artifact in a medical scan could lead to a misdiagnosis. This highlights why rigorous validation is absolutely essential and why users, like doctors, need to understand the limitations and perhaps the confidence level of the AI's output. It can't just be a black box.
So wrapping up our deep dive today, we've explored 4KAgent. It really does seem like a significant step forward, a universal generalist for image super resolution. Its ability to take all sorts of low-quality images and bring them into high definition using that clever agentic approach is genuinely impressive, with potential across so many fields.
It certainly is. And it leaves you thinking, as these AI agents get even better, as our digital tools develop sharper eyesight, what new kinds of visual information are we going to unlock? How might that fundamentally change how we see and interact with images, data, and the world around us when potentially everything can be viewed in crystal clear detail? It opens up some fascinating possibilities to ponder.